SpaceX is set to take its bold recycling initiative one step further next week. After a 3-month halt in orbital launches for SpaceX, the company's begun making a return to launch action. SpaceX plans to launch a batch of its Starlink broadband satellites aboard a Falcon 9 rocket that's previously flown 3 times and will use a fairing that flew in April. The SpaceX launch, set for November 11th, will mark the first Falcon 9 mission to use a payload fairing from a previous flight. The company announced Tuesday, the 5th of November, shortly after SpaceX engineers at Cape Canaveral test-fired the mission's first-stage booster. The SpaceX Falcon 9 launch, scheduled for next Monday and previously planned for October, will loft 60 Starlink satellites, which are part of SpaceX's new high-speed, low-Earth orbit satellite constellation. This is the first operational batch of SpaceX Starlinks to be launched, following a successful launch of the first 60 test satellites to orbit on a Falcon 9 on May 23, 2019. The launch window opens at 9:51 a.m. Eastern Standard Time Monday and extends for approximately 11 minutes. It will be SpaceX's first launch since August 6th and the first ground-based launch from Cape Canaveral since August 22nd. This will be SpaceX's 11th launch of the year, the 9th flight of the Falcon 9 in 2019, and the 76th Falcon 9 mission in total. In this video, Engineering Today will discuss SpaceX Falcon 9's next Starlink launch, which will reuse a Falcon Heavy fairing for the first time. Why SpaceX goes for 2 big reuse milestones with its next launch. Let's get into details. The U.S. Air Force-run Eastern Range at Cape Canaveral supported the October 10th launch of an airdropped Pegasus XL rocket over the Atlantic Ocean east of Florida. SpaceX has not said what caused the delay in the Starlink mission from October to November 11th. The SpaceX Falcon 9 booster that will be used for this mission, estimated to be flight-proven core B1048.4, was quickly static fired at 12:30 p.m. Eastern Standard Time Tuesday at Cape Canaveral's Complex 40 launch pad. The SpaceX Falcon 9's 9 Merlin 1D first-stage engines fired for several seconds, throttling up to produce 1.7 million pounds of thrust, while hold-down restraints kept the rocket firmly on the ground. The static test fire was a critical dress rehearsal of almost all the activities that will take place on launch day, so as to ensure that the rocket, ground systems, flight controllers, and the range are ready for the countdown and launch. Before the test occurred, SpaceX pad engineers rolled the launch vehicle, without the fairing and payload, out of the Horizontal Integration Facility, HIF, and to the pad, SLC-40. Once there, the rocket was lifted vertical and fueled up with super-chilled RP-1, which is the high-grade form of kerosene and densified liquid oxygen. Following a full countdown, the 9 Merlin 1D engines on the first stage briefly ignited, then shut off, signaling the end of the test. SpaceX has announced that the thrice-flown Falcon 9 booster successfully completed the static fire test, and the rocket's on track for a November 11th launch with the next 60 Starlink broadband satellites. Last month, a senior SpaceX official said the Starlink flight would be the company's first mission to fly a Falcon 9 first-stage booster for a 4th launch. The booster previously supported the launches of Iridium Next 7 mission on the 25th of July 2018, SOWCOM 1A mission on the 8th of October 2018, as well as Nusantara Satu and Bereshit on the 22nd of February 2019. For this mission, Core 1048 will be attempting a propulsive landing on one of SpaceX's autonomous spaceport drone ships, which will be stationed in the Atlantic Ocean for recovery. SpaceX also announced the mission would be the first to fly with a reused payload shroud, which shields sensitive satellite payloads during the first few minutes of flight through the thick lower atmosphere and protects the payloads from aerodynamic and heating stresses at launch. In addition to the Falcon 9 first stage, SpaceX plans to recover both halves of the rocket's fairing. SpaceX said the fairing on the next week's launch first flew April 11th on the company's Falcon Heavy rocket. The Falcon 9 and Falcon Heavy use the same type of clamshell-like composite payload shroud, composed of two pieces and measuring 43 feet, 13.1 meters tall, and 17 feet, 5.2 meters wide. The fairing jettisons from the rocket a few minutes after liftoff. Each half of the fairing is fitted with avionics, thrusters, and steerable parachutes to make a soft landing. The company wants to reuse the fairing, eyeing it as the next step in reducing launch costs and improving the landing and reuse of SpaceX Falcon booster stages. Other launch providers dispose of the fairing, but Elon Musk's space company has been working for a while now on different ways of catching fairings as they fall back to Earth. SpaceX plan to retrieve the components for refurbishment and reuse. Elon Musk told reporters last year that the fairing costs around $6 million. The fairing that'll fly next week was used on the Arabsat 6A mission in April that saw SpaceX Falcon Heavy successfully launch a huge telecommunications satellite. Reusing the different components of SpaceX's launch system is part of its drive to reduce the cost of getting to space, attracting more business in order to fund Musk's goal of making it to Mars. Ultimately, the next-generation Starship and Super Heavy booster the company is developing for Mars and beyond will be fully reusable, according to Musk. With fairing recovery, Falcon is 80% reusable, but reflight takes several days and requires boats, he wrote on Twitter on the 4th of November, Monday. Starship will be fully reusable with booster reflight possible every few hours and ship reflight every 8 hours. No boats needed. Neither of the two fairing halves recovered from SpaceX Falcon Heavy Block 5's Arabsat 6A mission were actually caught by fairing recovery ships Mrs. Tree, formerly Mr. Steven. Instead, both halves gently landed in the Atlantic Ocean, more than 1,000 kilometers, 620 miles off the coast of Florida, and were carefully lifted onto different recovery ships. SpaceX's tweet suggested both halves of the fairing will be reflown on the SpaceX Starlink launch. But it's not clear how much work needed to be done to clean them and mitigate the effects of any saltwater damage. One of the benefits for SpaceX of flying its own payload into space is that it can take the extra risk of reusing a fairing without having to convince a customer to do so. SpaceX CEO Elon Musk actually revealed that this fairing reuse was planned shortly after both halves were successfully lifted out of the water, indicating that both halves would fly again on an unspecified 2019 SpaceX Starlink launch. SpaceX successfully caught a fairing with a net for the first time after a Falcon Heavy launch in June. The giant net is carried aboard the recovery vessel Mrs. Tree. SpaceX has since outfitted a second boat named Miss Chief for fairing recovery missions. And the company could attempt to catch both fairing halves with the two vessels after SpaceX Starlink launch next week. SpaceX has modified the architecture of its Starlink network, which aims to provide global broadband internet service since launching the first 60 Starlink satellites in May. The Federal Communications Commission submitted documents to the ITU on October 7th outlining SpaceX's ambition to operate the 30,000 additional Starlink satellites beyond the 12,000 already authorized by the FCC. Gwynne Shotwell, SpaceX's president and chief operating officer, said in September that the company plans as many as 24 Starlink launches next year. These particular satellites also feature some slight design improvements compared to their previous iteration that in part were already planned and incorporated before the first batch of test satellites launched. They also include updates to address issues SpaceX encountered with the first batch of Starlinks. Each SpaceX Starlink spacecraft features a flat, compact design and is equipped with multiple high-throughput antennas, a single solar array, and Hall thrusters that are fueled by krypton, thereby enabling SpaceX to provide low-latency, high-throughput internet service to even the most remote parts of the globe. Each SpaceX Starlink satellite weighs about 500 pounds, or 227 kilograms, making the total payload mass up to 13,620 kilograms, which is 30,027 pounds. This matches the payload mass from the previous dedicated Starlink mission, which was the heaviest payload that SpaceX launched to date. The satellites launched in May each carried a krypton-ion propulsion system and Ku-band antennas for high-speed communication links. SpaceX is in competition with other planned satellite mega constellations targeting the broadband market, such as OneWeb and Amazon's Kuiper network. This initial batch of satellites will be launched as part of the first phase of SpaceX's Starlink deployment plan, which will see 1,584 satellites placed in 550-kilometer (342 miles) orbits at 53 degrees inclination. In August, SpaceX requested approval from the Federal Communications Commission to fly up to 1,584 Starlink satellites in 72 different orbital pathways, a change from the Commission's earlier authorization for SpaceX to operate the same number of spacecraft in 24 planes. SpaceX says the realignment will allow the Starlink network to begin providing broadband services to parts of the United States with fewer satellites and launches than previously planned. The SpaceX Starlink fleet could offer service to the northern United States, Canada, and locations at similar latitudes as soon as next year. The Starlink network could provide coverage over all populated areas after 24 launches, SpaceX said. Since first Starlink satellites launch, SpaceX has successfully demonstrated a range of capabilities, including streaming high-quality videos, playing video games, and more. CEO Elon Musk recently claimed to have tweeted over internet service provided by SpaceX Starlink satellites, likely signifying the first public test of SpaceX's self-built user terminals, ground antennas that customers will use to connect to the Space Inc. Starlink network. Gwynne Shotwell recently revealed that the U.S. Air Force has begun to carefully test Starlink's capabilities, part of a $29 million contract it awarded SpaceX last year. The U.S. Air Force is testing connectivity to high-performance aircraft and has sustained speeds of more than 600 megabits over air-to-satellite Starlink links. Impressive, but still only 3% of a single satellite's full bandwidth. Following this SpaceX Starlink mission, SpaceX will prepare to launch their 19th contracted commercially resupply services (CRS) mission to the International Space Station using the Cargo Dragon spacecraft. The mission is currently scheduled to launch no earlier than December 4th from SLC-40 at Cape Canaveral in Florida. Other missions on the short-term manifest for SpaceX include the JCSat-18 Pacific-1 mission and the critical Crew Dragon in-flight abort test, which are both slated to fly from SLC-40 and LC-39A, respectively. JCSat-18 Pacific-1 is slated to fly no earlier than December 15th. Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.